Hello everyone, welcome back to this online class. Today we are going to look at numerical solution of ordinary differential equations, and in particular we are going to look at modified Euler's method. Another name is Runge-Kutta second order method or Hens formula. Now we have this question. We are asked to use modified Euler's method to solve the initial value problem given by dy over dx is equals to 2x plus y, and the initial condition is that y of 0 is equals to 1. The step size is 0.2, that is h. Estimate the value of y of 0.2, y of 0.4, and y of 0.6 correct to 4 decimal places. So just to recall that the other name for this modified Euler's method is the Runge-Kutta second order, or it is also called the Hens formula. Hens formula. So those terms can be used interchangeably, but they mean the same thing. Remember, there are two Runge-Kutta methods: this second order, which we're going to look at now, and this Runge-Kutta fourth order method, which we look at later on. So let's see how to go about this problem. Now look at our ODE and the initial conditions. Our ODE is dy over dx is equals to 2x plus y. So the 2x plus y here is our f of xy. 0 here is our x naught, and 1 is our y naught. So we can list them here that x naught is 0, y naught is equals to 1. Of course, we know h to be 0.2, and our f of xy is equals to 2x plus y. So the iterative formula for the modified Euler's method is that yn plus 1 is equals to yn plus h over 2 times f of xn yn plus f of xn plus 1 yn plus 1. But this one I'll call it star. The star because it is different from the yn plus 1 that we have on the left-hand side. Star there means we have to predict the value and then we use it later on. So how do we get it? The yn plus 1 star, you can just say that where yn plus 1 star is given by yn plus h times f of xn yn. So it's like you're predicting and then you correct. Let me bracket this. So this is what you're calling Runge-Kutta second order method, or Hens formula, or the modified Euler's method, modified or improved Euler's method. So what is important is mastering the iterative formula in each method. Now let's see how to apply this formula. And remember, n is equals to 0, 1, 2, 3, etc. So if you look at our f of xy, I mean, let me bracket this one. I need to find f of xn, yn. So from here we can get f of xn, yn to be 2xn plus yn. and also f of xn plus 1 yn plus 1 star. What is this equal to? It is equals to 2xn plus 1 plus yn plus 1 star. That's what we have. Let's go back to our iterative formula. We start with n is equals to 0. You see what you're going to get. And also n1 etc. But before we start the iterations, this is the illustration of what we need to find. If I have something like this, what are we given? That y of 0 is equals to 1. So when x is 0, y is equals to 1. The step size is 0.2, so we go to 0.2. These are the values of x. Go to 0.4 and also 0.6. So the 0 here is what we are calling x0. 0.2 will be x1. This is x2. This is x3. 1 is y0, but I don't know the value here. That is y1. I don't know the value here. That is y2. I don't know the value here. That is y3. So the task here is to find the values of y1, y2, and y3. When we write y1, is the same as y at x1, which is the same as y at 0.2. That's what you need to find. y2 is the same as y at x2, which is the same as y of 0.4. And y3 is y at x3, which is the same as y of 0.6. So these are what we need to find. So what is the value? What is the value? And also what is the value of this one? So let's start. When we put n is equals to 0, what are we going to find? This is what we'll find, that y1 is equals to y0 plus h over 2 into f of x0, y0 plus f of x1, y1 star. Let us find y1 star. y1 star is equals to, you get it from here, when n is 0, that is y0 plus h f of x0, y0. And so this should give us our y0, that was 1, plus h is 0.2, then f of x0, y0, remember it's from here, f of x0, y0 will be 2x0 plus y0. So that's what we have. So I'll replace it here. 2x0 plus y0. Replace the values, that is 1 plus 0.2 into 2 times our x0 is 0, our y0 is 1. So when you press this in your calculator, what do we get? That will give us 1.2. 1.2. Of course, I ought to have calculated the value of f of x0, y0 here, because I still need it. That is 2x0 plus y0, which we have said is 2 times 0 plus 1, and that value is 1. So it is the value that I need there, that is 1. So having found y1 star, the next thing you need to find is f of x1, y1 star. That is the same as 2 times x1 plus y1 star. And that is 2. Our x1 is 0.2 and our y1 star is 1.2. When you press this in your calculator, you need to get 1.6. So now we know this, now, and we also know h and y naught. We can now be able to find y1. So you can just say hence, or simply therefore, y1 is equals to y naught, which is 1, plus h, which is 0.2 over 2, into f of x naught, y naught, that was 1, plus the other one is 1.6. So press this in your calculator. You need to get 1.26. So this 1.26 is the value of y when x is 0.2. So we have found it. So you can say this implies that y at 0.2 is equals to 1.26. So we have found this. This is 1.26. Let's proceed to find y2. Now, how do we get y2? We now put n is equals to 1. So put n is equals to 1. Of course, in the iterative formula, now that will give us y2 is equals to y1 plus h over 2 into f of x1, y1 plus f of x2, y2 star. So we need to find y2 star, but before we find y2 star, let's find f of x1, y1. So you can write this, that f of x1, y1 is equals to, it was 2x1 plus y1. And that is 2, our x1 is 0.2, y1 we have found to be 1.26. When you press this in your calculator, you need to get 1.66. So now I need to find y2 star. From the definition, it is the same as y1 plus h f of x1, y1. And that is the same as our y1 is 1.26, h is 0.2, f of x1, y1 is 1.66. Again, press this in your calculator. You need to get 1.592. 1.592. So what already I have this. Let me now find f of x2, y2 star. So write f of x2, y2 star. From the definition of our f of xy, remember we are getting them from here. From the definition of f of x, n plus 1, y, n plus 1 star, or simply f of xy, which is 2x plus y. So what we do here, it is 2 times x2 plus y2 star. 2x2 plus y2 star. That is 2. Our x2 is 0.4. Our y2 star we have found to be 1.592. When you press this in your calculator, you need to get 2.392. 392. So we have everything. Now we can find y2. So you can say that therefore our y2 is equals to y1, which is 1.26 plus h over 2, that is 0.2 over 2 into f of x1 y1, which we got 1.66 plus f of x2 y2 star, which we got 2.392. So when you press this in your calculator, you need to get 1.6652. 6652. So this is the value of y when x is 0.4. We are calling it y2. So you can just say here that y of 0.4 is equals to 1.6652. So it is the value here, 1.6652. So I have found y1, we have found y2. Let's also find the value of y3. So we proceed with the iteration. Now n is equals to 2. So you can write put n is equals to 2. Put n is equals to 2 in the iterative formula. So that will give us y3 is equals to y2 plus h over 2 into f of x2 y2 plus f of x3 y3 star. So we need to find y3 star, but before we find it, let's first of all find y2 f of x2 y2. So you can write here that f of x2 y2, from the definition of our f of xy, that is 2x plus y. So this will give us 2x2 plus y2. Do we know x2? Yes, that is 0.4. And do we know y2? We have found it as 1.6652. So when you press that in your calculator, you need to get the value of f of x2 y2 as 2.4652. 2.4652. So with that, now we can find y3 star. Check the definition of yn star. And in this case, n is equals to, of course, it was yn plus 1 star when n is 2. So you can find y3 star as y2 plus h f of x2 y2. And so our y2 was 1.6652. Our h is 0.2. F of x2 y2 we have found 2.4652. Let us press this in our calculator. That should give us 2.1582. 2.1582. So now we can find f of x3 y3 star. This one here. So you write f of x3 y3 star. That should give us, from the definition of f of xy, it was 2x plus y. So this will be 2x3 plus y3 star. That is 2. Our x3 is 0.6. Y3 star, we have found 2.1582. And so when you press that, you need to find 3.3582. 3.3582. And now we have everything, so we can now find y3. So right, therefore, our y3 is equals to y2, which we got as 1.6652 plus h over 2, h is 0.2, divided by 2, times f of x2, I2, that was 2.4652, plus f of x3, y3 star, that is 3.3582. Press this in your calculator. That should give you 2.2475. 2.2475. So this is the value of y when x is 0.6. So you can write here that this implies that y when x is 0.6 is equal to 2.2475. So we have found all the missing y values as required. So you can write here 2.2475. Now this is how to use modified Euler's method to work out or simply solve an initial value problem. Remember that the derivation of this iterative formula, you can find it from my PDF notes. Just spend some time and look at how to derive this iterative formula for the modified Euler's method. So thank you all for watching this video. Please subscribe to my YouTube channel, that is Professor Francis Okech. When you go to the YouTube search, type Francis Okech or Prof. Francis Okech, and you will find me right there. Also, don't forget to comment, like, and share this video. When we meet next time, we look at more problems involving numerical solution of ODEs. Bye-bye.